Have you ever felt that? You hear a really good song and the rhythm just feels right, almost like it's plugged into something way more fundamental than just music? Well, it turns out that's because it is. We're about to dig into how musical time isn't just for musicians. It's actually a kind of blueprint for how we make sense of the entire world around us.
So let me ask you this. It kind of sounds like a riddle, right? What could music, the words you're hearing me speak right now, and even computer code possibly have in common? Well, the answer is this incredible hidden structure, a shared system they all use to organize information over time. And it all starts with one really simple idea.
And that idea is the musical measure. You can think of it as our first tool for taking the chaos of raw sound and shaping it into something we can actually follow and enjoy.
So a measure, you'll also hear it called a bar, is basically a container. It's just a little box that holds a specific number of beats. See, just like you'd put things in boxes to organize a room, composers use measures to group musical ideas into these predictable, easy-to-digest chunks. It's literally what keeps 100 musicians in an orchestra all playing together perfectly. And this whole concept of boxing things up is definitely not just a music thing. Over in the world of statistics, they have something called data binning. When a statistician is drowning in raw data, they group it into intervals or bins. And this is the perfect example, isn't it? Whether we're talking about musical beats or data points, both systems are doing the exact same job, turning overwhelming chaos into clear, understandable patterns.
Okay, so if measures are the boxes, how do we know what to put inside them? Well, that's where the blueprint comes in, the time signature. The time signature looks just like a fraction. And if we take the most common one out there, 4/4 time, it gives a musician two absolutely critical pieces of information. The top number, the 4, tells you how many beats are in each measure, so 4 beats. The bottom number, also a 4 in this case, tells you what kind of note gets one beat. Here, it's a quarter note, so you put it together. 4/4 time just means 4 quarter note beats per box. It's really as simple as that. And that connection to math, to fractions, that's no accident. Now, they're not exactly the same thing. A time signature is more like a recipe, not a division problem. But they both tap into the very same skill, proportional reasoning. The part of your brain that understands a quarter note is twice as long as an eighth note is the same part that gets how fractions work. It's all about relationships and proportions. All right, so we've got our boxes, our measures, and we've got our blueprint, the time signature. But what gives music its feel, its groove? That comes from something called meter. It's the invisible pulse that organizes the whole shebang. Meter is that recurring pattern of strong and weak beats that you feel almost instinctively. It's what makes a march feel different from a waltz. The key here is that meter is like the grammar of a sentence. It takes all the individual rhythms and organizes them into a structure that actually makes sense. And believe it or not, that comparison to language is way more literal than you might think. I mean, think about it. The strong, weak pattern of a simple march is the exact same stress pattern you hear in the word cable. And that weak, strong pulse of a waltz, it's right there in the rhythm of a word like and a peak. Both music and language are built on these identical, fundamental patterns of stress. This is exactly why poetry and lyrics fit so perfectly with music. Now, these meters usually fall into two big families, simple and compound. The quickest way to tell them apart is to just look at the top number of the time signature. If you see a 2, 3, or 4, it's probably simple meter. That's where each big beat divides into two smaller parts, giving it that straight, march-like feel. But if you see a 6, 9, or 12, it's usually compound. There, each beat divides into 3 parts, which creates that cool, lilting, swinging feel. The reason simple meter feels so intuitive is because it is literally hardwired into our bodies. Just think about walking. Left, right, left, right. It's a perfect, strong, weak pattern. This kind of duple meter lines up perfectly with our basic biomechanics, which is why so many of us can't help but tap our feet or nod our heads to music with a simple beat. It just feels right. Compound meter, with its groups of 3, mirrors patterns we see all over the natural world. Think about wave motion in physics, for example. You often see smaller, repeating cycles that are nested inside a bigger primary wave. Well, that's exactly what compound meter is doing. It's nesting 3 little subdivisions inside each main beat. It's a beautiful system of cycles within cycles. So let's just pause for a second. We've got patterns linking music to statistics, to math, language, biology,
even physics. This is more than just a list of fun facts. It's pointing to some kind of universal code for how we structure information and experience. And get this, that code is even built into our technology. In computer science, algorithms run on loops, which are just repeated sets of instructions. A simple meter, that's like a basic loop. A compound meter, that's like a loop with another nested subloop inside it. Both need precise timing, predictable cycles, and a clear hierarchy. The very same logic that powers a folk jig is the logic that powers a computer program.
But hey, don't just take my word for any of this. You can find these patterns everywhere. Go grab a favorite poem and try to map out the stress patterns. Record a bouncing ball and see if you can hear the meter in it. Or even better, just get up and move. Feel the difference in your own body between a straight march and a swinging jig. I promise you'll start to see and feel these structures all around you. Which of course leaves us with one last big question. We've seen that the basic rules of musical time aren't really just for music. They reflect these incredibly deep patterns in math, in language, and even in the laws of physics. So if music is a key that unlocks this universal code, what else could it possibly help us understand?